Okay, we've talked about polar coordinates. Now we're going to talk about graphing polar equations. First one we're going to graph is r equals -4 sine theta. We're just going to make our way around the unit circle, putting in different thetas and figuring out what r would be with that. So I'm going to start with 0. Okay, -4 sine 0 would be -4 sine of 0. When I'm at 0, remember sine is the y coordinate, so it would also be 0. So that'd be -4 times 0, which is 0. I'm going to go ahead and plot as we go along so we don't lose, so maybe it'll come together. Okay, I want to be at angle 0, which is going to be along this line. And I want to be at radius of 1, so radius of 0. So I only want to, I'm going to be at the origin. So there's a dot there. Okay, my next angle that I come to on my unit circle would be pi over 6. So that'd be, let's write that a little bit better. Pi over 6. So that's -4 times the sine of pi over 6. Okay, you've got to remember your triangles. Pi over 6, if I put that in here, the short side is across, which would be my y distance, and the short side is 1/2. Remember, the long side was radical 3 over 2. We're going to need that in a minute. Okay, so 1/2 equals, so that would be -2. So at pi over 6, this angle, I want to go out -2. Well, here would be going out +2, 1, 2. If I want to go -2, I go the other way. So I go over 2 this way. So here's going to be my point. Next angle you come to on your unit circle is pi over 4. Okay, that's not drawn on this graph, but we know pi over 4 is going to land directly in the middle of those third lines. Okay, -4, sine of pi over 4. That's the 45, 45, 90 triangle, so this is radical 2 over 2. So that's going to give me -2 radical 2, which is roundabouts -2.8. So I'm going to go to pi over 4, this angle. Instead of going in that direction, I'm going to go the opposite direction, 2.8. Okay, next angle is pi over 3. -4 times the sine of pi over 3. That's your radical 3 over 2. That gives you -2 radical 3. Should be a little bit further out, -3.5. Okay, so my angle, pi over 3, go in the opposite direction, 3.5. Next angle we come to, let's see, we've done pi over 6, pi over 4, pi over 3. Next is pi over 2. -4, sine of pi over 2 is 1. It's 1 away, y distance, remember. Be -4. Here's my angle. I'm going to go in the opposite direction to draw my point. Okay, I'm working my way around to the second quadrant. Now I am at 2 pi over 3. Okay, -4 sine of 2 pi over 3. Well, remember your symmetry. This y distance is going to be the same as this y distance, and it's still positive, so I'm actually going to be repeating this right here. Radical 3 over 2 equals -2 radical 3, which is that -3.5. So that angle, opposite direction, 3.5. Next angle is 5 pi over 6, -4. Oh, sorry, skipped the fourth. Let's do 3 pi over 4 instead. -4 sine of 3 pi over 4, radical 2 over 2. It's going to be -2 radical 2, which we know is -2.8. And I got my angle. I go in the opposite direction, 2.8. And now 5 pi over 6, -4 times the sine of 5 pi over 6. That's going to be the 1/2. So it's going to be -2. I go opposite direction, 2. Now I'm at pi. -4 times the sine of pi, which is 0, is going to be 0. So I'm back at the origin. Okay, connecting my dots so far, I have made a circle. You do want to keep working your way around the unit circle. Make sure there's nothing more to that. So my next angle is going to be 7 pi over 6. -4 times the sine of 7 pi over 6 is going to be -1/2. So that's going to be a +2. Let's see what that looks like on the graph. If I'm at 7 pi over 6, I'm here. Okay, if I'm at 2, I'm here. I've already got that point. Let's see what's going to happen with 5 pi over 4. -4 times negative radical 2 over 2, positive 2 radical 2, which we know that's the 2.8. And we already have that point. Okay, so what's happening here is it's going to overlap. It's going to make that same circle again. If we needed to complete the table, we could. We would have 4 pi over 3, which if we check our symmetry would be 3.5. Then we would have 3 pi over 2, comes out to be 4. 5 pi over 3 comes out to be 3.5. And last but not least, sorry, we're not even there. 7 pi over 4 gives me 2.8. 11 pi over 6 gives me 2. Now, last but not least, 2 pi should be the same as 0, which was 0. Okay, so after a while, I could figure out that, oh, this is just repeating. Sine on my quadrants 3 and 4 is just the negative value, and since I was multiplying by a negative, they all became positive, which is overlapping what I already drew. Now, about this graph. This graph does have symmetry. When you're looking at symmetry, you're looking at the horizontal and the vertical axis. Okay, well, it doesn't have symmetry this way, because otherwise I'd have to have another circle up here. It does have symmetry this way. I could cut it in half with that vertical axis. What is that vertical axis? It's pi over 2. So we would say this graph has theta equal to pi over 2 symmetry. Okay, a little diagram to help you with the symmetries. If it has that theta equals pi over 2 symmetry like we just talked about, everything on this side on the right side is reflected over to the left side. If you're looking at it coordinate point wise, this would be -r negative theta, or r theta minus, or pi minus theta. Different ways to represent it. I don't get super caught up in all this as long as I can see it graphically. Okay, if it had horizontal symmetry, ours didn't, but we would say that's respect to the polar axis. And then if it was opposite, kind of like our symmetry with the origin, it had to do the flip and the flip. That has symmetry with respect to the pole. Now the origin is called the pole. Horizontal is called the polar axis, and this is the line theta equals pi over 2. If you wanted to test for symmetry, you could use those tests. In that case, you'd be memorizing or writing out diagrams. Determine the symmetry of r equals 4 sine theta. You could absolutely do this by graphing to determine. If I do it with these tests, okay, it is already written with r and theta, and this says if I'm testing for theta equals pi over 2 symmetry. Replace r and theta with r and pi minus theta, okay? So r stays r equals 4 times the sine of pi minus theta, okay? You have an identity sheet that tells you that that's going to be the same as r equals 4 sine theta. If I wanted to use the other test, which I actually think is a little bit easier, I keep r as negative r equals 4 sine of negative theta, okay? Negative r equals 4. You have an identity that tells you when sine of negative theta, you can bring that negative out front and make that theta positive. And then if I multiply by a negative, I have 4 equals r sine theta. Okay, so this does have theta equals pi over 2 symmetry. If I test for another one, okay, now let's test for polar axis. Okay, if I test for polar axis, I'm going to use this one. So instead of r equals 4 sine theta, r stays r equals 4 sine negative theta. R equals, we learned that you can take that negative out front. And that is not the same as the original. So this would not have symmetry with the polar axis. If I try pole symmetry, replace r theta by negative r theta. So negative r equals 4 sine theta stays theta. That is still not the same as the original. So on this graph, it's only going to have theta equals pi over 2 symmetry. The funny thing about symmetries, and this is why I'm not a huge fan of testing for symmetry, I'd rather just work my way around the whole circle, is that if I was testing, let's say, theta equals pi over 2, and I tested it with this, and it didn't work, I would say, oh, it must not have that symmetry. But this could work when this doesn't work. So I don't know, I'm not a fan of testing symmetry, but if you want to memorize these to make life easier, you go right ahead. Okay, this is a little tidbit of what I said before in writing. Your graph could fail all the axis of symmetry tests and still have symmetry. Quick way to remember it is if you have sine graphs, they're going to be symmetric with pi over 2. If you have cosine graphs, they're going to be symmetric with the polar axis. So sine graphs are the same on the left and the right. Cosine graphs are the same on the top and the bottom. Okay, if I know this graph is a cosine, it's going to be the same on top and bottom. I really only need to go 0 to pi. So this is what I'm saying is if you know your symmetries, you can shorten the amount of time you use making a table and writing your graphs out. Okay, so if I start at 0, 4 cosine 2 theta. 4 cosine of 2 theta, that's going to be cosine of 0. So that's going to be 4 times 1, which is 1. And by 1, I mean 4. I put a 4 there. Angle 0, go out 4. All right, next angle, pi over 6. 4 times the cosine of double that would be pi over 3. I'm doubling it because of that 2 theta. Cosine of pi over 3 would be 1/2. 4 times 1/2 is 2. So on my pi over 6, I go out 2. Pi over 4. 4 cosine of pi over 2. Cosine of pi over 2 is 0. I get 0. So far, this is what my path has done. All right, continuing. pi over 3. 4 cosine. If I double pi over 3, I get 2 pi over 3. And the cosine of that is negative 1/2. So now I have negative 2. So pi over 3, I need to go to the other way. Okay, pi over 6, pi over 4, pi over 3, pi over 2. 4 cosine of pi. Cosine of pi is negative 1, so that's 4 times negative 1, negative 4. For the other way. Pi over 2, now we're at 2 pi over 3, 4 cosine of 4 pi over 3, which is still going to be negative 1/2. Gives me negative 2. To the other way, so my path now, I've come this way. After 2 pi over 3, we get 3 pi over 4. 4 cosine of, if I double 3 pi over 4, I'm gonna get 6 pi over 4, which is 3 pi over 2. Cosine of 3 pi over 2 is 0, which is 0. So now I'm back here. So my path goes back to the pole. 2 pi over 3 would be 5 pi over 6. 4 cosine, that would be 10 pi over 6. So that's 5 pi over 3. Cosine 5 pi over 3 would be positive 1/2. So that'd be 2. So at 5 pi over 6, I need to go 2. And then last but not least, we've got to do pi. 4 cosine 2 pi, which is 1. 4 times 1 is 4. Okay, I know it was a cosine equation. I know it has polar axis symmetry. All I have to do is reflect what's on top onto the bottom, and what's on the bottom onto the top. So it takes a little bit of the work out of it. Here is a reference on ways to remember. If you look at the equations, if it's a plus or minus something cosine theta, or a plus or minus b sine theta, and they're both positive, you're going to make a lemicon. If it is, let's see, if you're multiplying theta by something, you can look at what theta is being multiplied by and make something with petals. When n is odd, 2 n petals, or n petals when n is odd, 2 n petals when n is even. So there's a way to remember that. Circles and lemniscates. Just look down here if you can recognize these. Lemniscates are pretty obvious, but they have the r squared. And they go out a, so you can figure out what you're squaring out here. It also is a 2 theta. Now you'd think petals because of the rose curves on the page before, but since they're 2 and not above 2, they're a lemniscate. Okay, so analyze the graph of 3 cosine 3 theta. If you remember, it's going to be a rose. Okay, this matches that r equals a cosine n theta. My a is equal to 3. My n is equal to 3. Now what does this mean? When I have n petals, when n is odd. N is odd, so I'm going to have 3 petals. And on the drawing, it showed you that they always go out a 3 in length. So a 3 out to the side. Okay, 3 petals, they go out of length of 3. Let's get just a few numbers on my table. If I start at 0, 3 times the cosine of 0. Cosine of 0 is 1, so this is just 3. So there's the end of one of my petals. Pi over 6, 3 cosine. Now 3 times pi over 6 is going to be pi over 2. Cosine of pi over 2 is 0. So then I come here, and then let's do pi over 4. 3 cosine of 3 pi over 4 is going to be 3 times negative radical 2 over 2. So, and that roundabouts to negative 2.1. So at at pi over 4, I need to go in the opposite direction a little more than 2. And then pi over 3. 3 cosine, 3 times 3 pi over 3 is going to be pi. Cosine of pi is negative 1. So I have negative 3. So I go to pi over 3. This angle, I'm going to go backwards 3. Okay, so I traced my path. I've gone from 3 to 0 to down here. Now, I know that it's 3 petals, and I bet I've got the tip of 2 of my petals. The widths always are symmetrical, so I can sketch those in. Okay, and my third petal has got to be equal distance, so I bet it has to be out here. Same width. I can draw in all my petals just by knowing that this is the length of my petals, this is how many petals. It was a cosine graph. Analyze the graph, r squared. We know we're going to be talking about lemniscates. Looks like the infinity symbol. For lemniscate, we had r squared equals a squared cosine 2 theta. So my a has to be 2 in order to fit in here with the 4, and that was the width. So basically, I need to put an infinity sign in here with a width of 2. How wide is it? That's where I need to at least punch in a few numbers. Theta at 0. Okay, that's going to be 4 cosine of 0. Remember, oh, this is for r squared, then we'll have to find r. 4 cosine of 0, that would be 4. And then if I take the square root of that, I get 2. So I'm here. If I go to the next angle, hopefully that'll give me my width, pi over 6. 4 cosine, that's going to be pi over 3. So that's going to be a half. 4 times a half is going to be 2. Square root of 2 is going to be 1.4. So I know I go out this far. Pretty much all I need to be able to sketch this graph. I know it's going to come out this way. Should have hit that point a little bit better. And it's got to do the same thing on the other side.